We now move on to the second lecture of the day, titled AI/ML applications in varied areas like computer networks, software safety, biometrics, uh, education, and business, which will be delivered by Professor Anu Gokhale.
Okay, thank you. Okay, so we begin with lecture 6 now. Day 2, lecture 6, AI and ML applications in varied areas like computer network, software, safety, biometrics, education, and business. Okay, so here's an outline. Like I said, I'm going to talk about my team's research studies. We have a research team. I'm part of research team in the U.S., Brazil, China, India. Why Brazil? Because I went there on a Fulbright. I was a distinguished chair, Fulbright distinguished chair in STEM, and we were doing research in computer networks in China. I was invited as a visiting faculty. I was there for 10 weeks, and it was big. And that's where we did research on biometrics. And of course, India, my association has been for a long time. We had a visiting professor from India at Illinois State University all the way back in 1997. He was from Anna University, and we established a very nice working relationship, and we did some research. After that, I broadened my application because I was a Fulbright scholar at IIT Mumbai, and also at MAHE, Manipal Institute of Technology in Karnataka, in Manipal. And so at both places, then we had research groups there. So that's where I'm going to talk about that. And then finally, as you know, we will end with a motivational quote. So let's begin. Okay. Multiple National Science Foundation funded projects in STEM recruitment and retention, especially in computing. So this is more about education. Our biggest contributions, I would say, would be the intellectual merit or creative solutions. Engage the millennial generation through online learning communities and establish the value of peer-to-peer social network. So this was all the way back in 2005. So in 2005, if you know, like 20 years ago, there wasn't that much of social networks, right? Okay, so at that time we had peer-to-peer networks. We used that as a strategy to engage students in STEM and to enhance their the research capability of the students. So undergraduate and graduate students were involved in research, created the second contribution. This is with a separate grant, okay? This was for K-12 teachers to earn a computer science endorsement, because computer science was not taught in middle and high schools. I don't think we even today teach in India computer science in schools, right? K through 12, or only up to 10th or whatever. So, but I don't know so much about it, but it wasn't. And that's what our program was, to establish a computer science endorsement. So teachers could teach computer science, and then students would be exposed, and then they could earn, the computing degrees. So I'm just going to talk about projects because, like I mentioned, we were funded for over 20 years consecutive grants from National Science Foundation, which is similar to DFT here, Department of Science and Technology. Traditional methods like statistical analysis, we of course use regression, factor analysis, ANOVA, MANOVA. Newer techniques like data mining, clustering, nearest neighbor, decision trees, neural networks, all of those we have used the algorithms. And questions being asked: what patterns are there in the database? Which patterns are significant? What is the chance that an event will occur? And then what is a high level summary of the data? So those are some general purpose, just summarized questions. Here are some factors that we were using, like, based on, like I said, how large the data is, you can determine how many factors you can have. So we were looking at the overall GPA, the major GPA, whether they had a scholarship or not, peer tutoring and mentoring, because in the US it is common for a hire, like to hire seniors to teach the first and second year students as peer mentors, or to actually help them learn, solve problems regarding the academics. Okay, so that is common. That is what peer tutoring and mentoring is. Club affiliation, like it could be an ACM or IEEE, stuff like that. Participation in online learning community, that's the one that we designed. Participation in seminars, we would have people from business and industry come to the classroom. Perceived job opportunity, perceived appropriateness of career choice, and support from family member, teacher, or advisor. So pre-post differences, I can see this was a normal distribution. That's something for a statistical. You have to establish that you have a normal distribution, so on and so forth. And then we will look at pre-test data and then the post-test data, and you can see that our this was using the K neural network algorithm, so on and so forth. So the results of the KNN and decision tree chain prediction with over 70% confidence, that is important. Like how much confidence do you have, right? Okay, and this was, look at the bold statement here, agreement between results obtained by statistical analysis and data analytics. Okay, so both methods were used, both methods, and that's what I talked about earlier, the power of the test. The power of the test goes up when you use both statistical and algorithms. So then it was found for female retention in STEM, their major GPA is important. The fact that they participated in the online learning community, support from their family member or teacher, and their participation in seminars, and perceived appropriateness of career choice. For males, it is completely different. Major GPA is common, but then they were looking more at the job opportunity, the finance. So it's more about finance and money for males, while for females, it is more about the other soft factors, as I would say. So a little different for males versus females. Okay. So let's look at what our work was in Brazil. Not was, but still is going on. Okay, so reinforcement machine learning algorithm examples from our research, the next gen networking. We were doing research in mobile ad hoc networks, which are continuously self-configuring networks of mobile devices connected, basically, mobile networks. Ad hoc on-demand distance vector, that is the most common routing protocol. So our research was in routing protocol for computer networks, for mobile networks. Okay, so the most common one is ad hoc on-demand distance vector. What we did was to modify I'm just giving one study. We have done multiple studies after that, but and it's still happening. Our research introduced the concept of node connectivity. Node connectivity is determined as the number of neighbors a node has. The hypothesis is that more connected nodes can find feasible routes than less connected ones. And that's also true if you look for it, like in any communications, like the more friends you have, the more ways to find information or to disperse information, or even to share or to acquire. If you have only one friend, then whatever only that one friend knows, you will learn and you will share with that one friend. Okay, so that's the whole idea. Like nodes can be like friends. You can think of them as people. Okay, and then the ways, channels to spread it, the more communications that can happen. So modified AODV pseudocode, of course, the A, B, C, and D, they are the weights, as you can see. An optimizer determines the optimum values for the weight. So we don't determine the values, the optimizer does that. The source would have the packet forward and source connectivity, And then the local would have the predecessor hop count and then the predecessor connectivity. And if source is less than or equal to local, then local repair, else source repair. So it depends on where you want to repair the connection. Do you want to repair it locally? Do you want to repair it at the source? Because it's all about seamless connection, right? In communications. So we were working with the Network Simulator 3 and multi-objective optimization algorithms. Moves, as they are called, find a set of non-dominated solutions regarding all solutions examined and approximate as best as possible the real Pareto front. This study primarily used all these different algorithms, and we are going to talk about those: the non-dominated NSGA, the speed2, so on and so forth. And this one is the swarm optimization, particle swarm optimization. We had more than one. Okay, so let's talk about the performance metrics to evaluate the multi-objective optimization algorithms. That's what the MOVE stands for. Multi-objective means you have multiple objectives, okay? You want to achieve this, achieve that, okay? Multi-objective optimization. You want to optimize on each one, not just one and then forget the other, okay? Optimize on each one. So multi-objective optimization algorithms. Throughput, this indicates the amount of data that is transmitted, right? Throughput, end-to-end delay, that was the second objective. Packet loss ratio measures the fraction of data packets that was not delivered to the destination, and energy consumption, of course. Any communications problem, minimize energy, correct? Yeah. Important, humans set the goals and the machine learning model figures out how to achieve that goal. Researchers do not know how the system used the data to achieve the goal. This is something we all have to remember anytime we look at an algorithm, because we set the goals, we use this data set, we set the goals, and then let the algorithm work through the data to achieve those objectives. So here is the results chart. As you can see, the algorithm that was used, the 4 objectives, so multi-objective, throughput, end-to-end delay, packet loss ratio, and energy consumption. And each one, AODV is the standard that's like currently used. And then as you can see, it is concluded that the results achieved by all of the variations are superior to the standard AODV, but AODV plus particle swarm optimization seems to be most effective, meaning optimized on all the 4 objectives, okay? So this is something you can apply the same thing for a different problem where you have multiple objectives. The reason I'm giving you these examples is it doesn't have to be computer networking. It can be a problem where you have multiple objectives and you can be using a few algorithms, run on that data set, run in the simulation. Many of these are simulation environments for all, because I have been an external examiner for some PhD candidates, at different universities. So I get their research dissertations basically emailed to me, and then I read them and review and give feedback. Sometimes I'm on the committee, so I'm involved a little bit beginning, so on and so forth. But the thing that I have learned from what I have read in the last 2 years, say, I'm only focusing on the most recent ones, is a lot of research has been done in energy. Okay, some of it has been like how do you structure the energy, the basically how should I say, the distribution of energy, because we use solar, we use, it was a combination of basically solar and the traditional, of course, the, energy that is used through any power plant. Then how do you distribute it to make it an efficient system? So let's talk then about the work that I did in China, which was more on biometrics, unsupervised machine learning algorithm, examples from our research, non-invasive facial recognition. So the whole objective of that research was to understand the emotions on the face. Okay. So the research group was using optical spectroscopy as an analytical tool combined with two-dimensional object visualization. I propose that we investigate a relatively novel approach that employs hyperspectral imaging to remotely sense objects. This is a way to do it's a little more expensive, I should say. The experimental setup is complicated and expensive both. Okay, so it's not something that is something routine, because the hyperspectral camera itself is quite expensive, and then to set it up and get all the images, get the people in the right way to get their images, it all takes a lot of investment. So distinguishes blood chromophores in facial tissues and acquires an evaluation indicator, which is the tissue oxygen saturation, STO2, using an optical absorption model, remotely detect emotions in humans based on STO2. The biggest part is non-invasive, as you can see in the title of this slide. Non-invasive is nothing touches our body. So it's non-invasive, okay? So remotely detects something. And then facial recognition, so remotely detects emotions in humans. It took us a while to perfect the experimental setup, which is to be expected for innovative scientific. Like it took easily like 4 to 6 weeks, okay, to actually do the experimental setup and make sure it was accurate and everything. So that's why I said it does take investment in terms of money and time. Standard RGB imaging versus hyperspectral. Let's talk a little bit about standard versus what is hyperspectral. Standard RGB, red, green, blue, used in digital imaging like cameras. All our cameras basically are RGB, right? Computer screens, printers, they are images obtained on narrower discontinuous channels. Here I show you the R, G, and P. Detects size, shape, and visible color, but not chemical or biological processes. That's the biggest difference, okay? So anytime you want to detect chemical or biological processes in an image, then you need the hyperspectral imaging. Okay, so what does hyperspectral do? Captures information from a large number of continuous wavelengths. So not just RGB, that's the biggest difference, okay? It from the continuous wavelengths, because we know that, you know, the whole spectrum is from our the visible light, right? Detects biological and chemical processes and bioorganisms. And I will talk about some of the applications later, like they are used in agriculture, for example, to determine how fresh is your vegetables, fruit, you know, if there is a disease happening in something. So a lot of agricultural applications for hyperspectral imaging. Okay, expensive and complex technology. So I'm saying that right from the start, don't think of it as something that you can do quickly. You know, be prepared to invest, have some, you know, way to invest time and money. Unless the costs are different here, okay, I don't know, but I know in China they were expensive compared, and I'm sure they will be expensive here compared to the standard cameras, okay, naturally. HSI camera, which is the hyperspectral imaging camera, detects biochemical differences using the tissue oxygen saturation. So this is what happened. That were this is what the experiment was. We gave them a script to read, okay, the people, and we were only trying to detect the emotions of the person. So the script was given, and one of the script made the people angry because whatever the story wasn't a very positive or a nice story. It was something that would make a person angry. And the other story was something that was like a little light comedy kind of thing that would make people smile. Okay. So then we had two different images like of people, and we did get a difference. That is the biggest, it's significant difference between the two. Important, humans label the outcomes of AI system. Now this data is not telling us, oh, this is a happy face and this is an angry face, right? We know what the people did to get that face, and then we say, this is a happiness data and this is what's the anger data. You understand what I'm saying? Why I say label the outcomes based on the domain knowledge, because we know this kind of story will make humans smile and this will make humans angry. You understand what I'm saying? That's where our human experience, that's why I said don't leave that at the door and only look at data. Bring that with you into every study so you know how to apply and how to use it. Okay. So HSI uses in everyday life. I thought I'd bring this because there's so much IoT today and so on and so forth. So I thought, how do I tell my participants in the program how they can use hyperspectral imaging for what? Okay, detection of the emotions can be in product development, learning analytics, okay? Any kind of um, agriculture, detect early symptoms of diseases in crops, because that's a big deal, right? A lot of agricultural output is going to depend on, hey, were you able to detect the disease early and address the situation, correct? Food quality and safety, detection of early decay or harmful pathogens, bacteria, fungi, etc. in fruits and vegetables. So basically, any bio or chemical processes. Remember, biological processes or chemical processes, which really our normal camera is not going to detect unless you see a black spot on a fruit. Then you know that, oh, I see a little decay. But before that, what is happening inside, we are not able to see. Get it? Okay, but these cameras are going to detect that inside and tell you, oh, in 10 days, this fruit is going to go bad or whatever it may be, okay? So stuff like that. Even on trees, for example, even before an attack can happen,
Sorry, CK, MMD taxi on what in Madam, I have a two question. Let's talk about the first one, and that is HSI power, right? It has some wavelength range. So, can we use the range of the wavelength for recognizing the human face and human emotions? Like in the wavelength range, we have a 600 to 800, which is colored with the green and yellow, which can be related with the hairy face. And about 800 nanometers of the wavelength, we can categorize as a sad face, because I have just looked with two human faces with the happiness and the sad emotions, and I just relate those number of pixels of a different colors in a wavelength. So can we use the wavelength of the HSI different colors for recognizing the human emotions? First question. And second is related with the error laws, wherein you have performed certain research studies for getting connections of the different mobile phones. Now, my question is related to the ultimately the purpose of the connectivity is to communicate. So, because in this area, my mobile is connected with the networks, and I send hello message to the receiver. And just I go out of this classroom, my mobile phone gets disconnected. So, what will happen with the message, which was already sent in a connected area, and then the mobile phone gets disconnected? So, that hello package will be lost in the network, or hello package will be stored in some buffer in a network, or hello package will be received by the receiver after some delay. So what will happen with that package?
Okay. So these are two distinct questions. They are not at all related, right? Because one is about networking and the other is about the HSI. Hyperspectral imaging, I would say, yeah, you were talking about, oh, from this to this would be a happy, this to this would be a sad. This is also based on our research, the research that has been done. So yes, that can happen. Although I would definitely uh, uh, do a more thorough study if those demarcations of wavelengths are accurate or not. Okay. So that would be my response to the first question. A response to the second question, you send a hello here. Maybe some phones received it, maybe some didn't, maybe some are going to receive it later, whatever. But basically, anything that goes in the network, definitely stays in the network. Nothing is ever lost. Okay. Now, where it stays and how accessible it is the question. How accessible? Who can access it? Anything can be accessed if you put your efforts into it and put the invest time, resources. Anything can be accessed. That's how FBI or any of the investigation agencies, they pull out records from where and when, and everything. So everything that is sent, even if you type it and don't even send it and it stays in your phone, that itself can become data. Okay, so that would be my response. Okay, so let's look at another application of HSI used in criminal investigations. Okay, forensic science, arson investigation, fiber comparison, blood stain visualization. All of these are HSI applications. So if arson, actually, sometimes because of all the wildfires that you may have heard, wildfires have become quite common in the US. And so, there's a question of, was there arson involved, or was that just natural, and what caused it, and so on and so forth. So a lot of investigations use forensics is a common branch, and a very, it uses a lot of digital technologies, forensics. And for that, the HSI detection becomes very valuable. Medical diagnostics, normal versus malignant tissue. So, malign, anything, it's going to show different colors rather than just shades of gray, as Eve was also sharing with me. If you can have a more HSI imaging, which would go more into the biological and chemical and kind of distinguish, then you would have a more realistic picture of what is happening rather than just a black and white image. Cultural artifacts, relics, murals. Anybody in archaeology, would find value in. We have in India, there is so much of culture, right, and relics, and so much to be preserved. Well, there is a lot of value in using the HSI for protecting those murals and for detecting and so on, and detection even that it exists, underground or wherever. So let's talk about software safety, which the research team, like I said, which started all the way back in 1997. And then I created additional teams in 2003 when I was a Fulbright scholar at IIT and Manipal. Our initial work was in fuzzy logic. The idea that truth is stated as a continuum. In other words, an event is not categorically true or false, but basically partially true and partially false. That's what happens in all of the situations. It's like, will this cause this? Well, maybe not, right? We have to look at other factors. Okay, so that's the whole idea behind it. And when we started in 1997, of course, there was no big data or anything like that, no data sets available. So we were working with models actually for software safety, like train safety, So we actually had models created, and, we had the controllers and everything. So I'm just showing you the setup that exists in the 90s versus the setup that exists today is quite different. Okay. So, today it is almost like 25 years later, where there's so much difference in technology. Traditional algorithms for software safety investigate software design approaches to identify faults in safety critical systems and reduce the risk of accidents. That's the whole idea about software safety, right? Air control systems or any other fault tree analysis. If you know how fault tree analysis works, you always look at all the different the faults, like the final system failure. But the system failure doesn't happen due to just one thing. It starts at the bottom. There has to be some incident, then there is failure one. Then after failure one, then there is something else that happens, then failure two. Then it's pretty hierarchical, right? So the failure modes and effects analysis, this is how that model looks like, where you have the likelihood of it's the accident happening, so it's high, extreme, and then reasonably probable, possible, remote. So all different categories of likelihood, and then the minor, marginal, critical, or catastrophic outcome. Okay, so it depends on what the outcome is, and then you look at that's basically the chart, and that's how we classify all the different instances. And then the fuzzy logic based supervised machine learning algorithm was the one we used. The innovation in our approach was to extend our work by designing fuzzy logic based machine learning algorithms for supporting predictive analytics using transportation data. So we took what we were doing in 1997 and I transitioned to the data, so we kind of keeping the same mode of study. Transportation systems are characterized by uncertainty, ambiguity, and imprecision, making it the prime candidate for fuzzy logic. It's never a yes or a no. It's always a shade of gray, right? That's what fuzzy logic is. It's not zeros and ones. Okay. Multi-agent machine learning systems allow many-to-many communications, one-to-many, one-to-one, right? There are ways of communication systems classifying them, many-to-many communication for traffic control and safety based on real-time conditions. Agents perceive their environment and respond in a timely fashion to environmental changes. Agents collaborate to achieve a global model. So this is how we had the fuzzifier and the defuzzifier. Okay, so it's just like a multiplexer and demultiplexer. It's a fuzzifier and a defuzzifier. And in the middle is the controller and the software safety. Our team designed a self-learning system which assigns weights dynamically. Remember the weights, even for the other computer networking, the weights were assigned dynamically because we don't give weights. The program or the algorithm determines the weights to multiple inputs based on past instances to produce a single output. So it depends on how the data is continuously updating the weights that are given to the multiple inputs. Fuzzy logic-based unsupervised machine learning algorithms for geospatial big data device algorithms that can expeditiously handle large data sets and reduce response time. The use case in our study was geospatial query, like basically where is it located, like Google Maps. Google Maps is a geospatial query. So technical term for something, that we use all the time. K-means or K-weighted means are unsupervised learning algorithms that were used. And so before the error control, after the error, I'm just showing you the different graphs that come up. Interpreting the data is very important. What are the results that you're getting and how do we interpret them? So again, humans set the goals and the self-learning algorithms figure out how to achieve that goal. But researchers do not know how the system used the data to achieve that goal. And the reason I tell you all this right now, because later on I'm going to capitalize on it, okay? So homework now. Now I have some homework for you. Okay, I was just talking with Dr. Makwana. These are some research studies that I downloaded in the US, okay, something that I haven't done. These are articles that are not published by me. I don't want to give you something I did, okay, for a reason, because, it's not about me. It is about you learning from everything else. So I categorized them into 5 areas: healthcare, manufacturing. There were some transportation, but there were, and you can pick the 2 articles. There are some that are in education, some are in ethical AI, but even ethical AI gives you different categories. Ethical AI can be applied for all different purposes, okay? So those articles are available. I have total of 26 articles, and what I was thinking of is having one article read by at least 2 people, maximum 3, because 26 times 2 is 52. We have minimum 52 participants here. So we will definitely have 2 people per article. And then you will be presenting, okay? So on the last day, you will be so it gives you a chance to showcase your communication skills. your oral communications, and only one slide permitted per person. So if you are two people, each one will speak for 1 minute. Okay. So each one, it's not like, oh, we two did together, this person spoke, so now I don't have to speak. No, every person, even if you're two, the two is just so you can communicate with other what they found and discuss and so on and enhance your understanding of what it is that you read. Okay, it's always good to discuss with somebody. So that's what, but you will be presenting and we'll be talking more about that, about the mechanics, but that will happen on Friday morning. Okay, Friday morning, each one of you will be presenting, you will be uploading your slide and we will tell you where and everything like that. And Dr. Makwana has your emails and he will be emailing you and random emails. So it's not like, oh, I want healthcare, I want agriculture. It's not like that. He is going to email randomly. Okay, and so would I, and then if you decide, hey, I have this and I have that, I would love to do this, and you somebody else, I would love to do that. It's okay to exchange. I'm not, that is not a problem. Okay, but initially asking is going to be an issue only because then it's a headache for him. Okay, to determine who gets what. So that's going to be the whole idea for homework for lecture. I'm saying assigned in lectures now, but then not 9 and 10 because we will be doing, this is more for Friday because this was lecture 5 and 6, 9 and 10 will happen tomorrow. But I'm not giving it to you for tomorrow, okay? I'm giving it to you for Friday. Sounds like a plan, Dr. Makwana. Do you want to say anything more about what I just said?
We will send the. Yeah, you will.
Oh, okay, okay.
Okay. Okay. We will send the paper to the everyone in their email ID, and you pick up the one papers, and at a part of the assessment point of view, there is a one presentations as Madam is told. So based on that one, we will give the give the weightage of the assessment criteria because at the end of this course we have to give the grade history about this course. Okay, and also we will take the one MCQ type question also. Okay, and maybe it will share in your email ID by the Friday mornings. Okay, so this is the two criteria that will decide your grading. The grading is not for the anything, but as a part of the GYAN guideline, we have to give the grading of the this course. Okay, so by Friday we will in the 2 hours the presentation will be done. Okay, yeah. And then after we will give the time for the assessment also. And if possible, maybe we will take the lecture also, the remaining part of the any topic during the lectures.
Yes.
Yeah.
Right. Is present.
Huh?
Price will be this is a
Price. Okay, okay. We will decide.
No, it's a participation. Remember, that's the millennial generation. So it's all about participation certificates for just participating and just appreciation for everybody.
Madam is-
People have certificates, so no one will be. No, I don't believe in having competition. And really, there can be each one of you. Maybe it wasn't your right moment when you presented that day, Friday morning. If you were given one more hour, it could have been completely different. So you know what? We are not going to be judgmental, okay? We are just going to be appreciative of the efforts that you put in, okay? So put in the efforts. We are going to be appreciative of what you did, the work that you did. What do you have to do with the article? Identify the problem of the study. Can you show the slide, please?
Right.
Yeah, okay. Identify the problem of the study, the research methods, databases that were used, machine learning, whatever. Each article is different, may not have the same requirements. So you might say, oh, my article doesn't have a database. It is more philosophical and more theoretical and all these different. Fine, just present that, okay? There is nothing like, hard and fast about what you need to do, but I'm just giving you some guidelines about whatever the article is. Make sure you are able to extract the essence of the article. That's what the whole idea is. And I have read each and every article, okay, by the way. So those 26, because I put in a lot of work for this course, okay. So I have read each and every article. And I know that these are quality articles, is what I'm trying to say. Based on the area and the application for it, okay, more application oriented. And I think you will learn, and you will learn from every other article that is presented, right? That's why I'm asking each one, and then just pairs, so that you get somebody to work with. It's not like you're working alone, okay? And each one will do something different. Don't repeat. Like if two people are doing the same article, make sure the two people talk something distinct from each other. Understand what I'm saying? Okay, don't make it identical, make it separate. Okay, you talk about this, I'll talk about that, and that would be good. Anything else? Any other questions? Because that's a big deal. That's going to be done today. That way you will have 2 or 3 days, and he will tell you who your partner is, who has emailed the same article. Okay, you will come. Will they know? Oh, then they have to find out among themselves. You can take 2 emails and just email them in a group like that. One article, just pick 2 emails, and then they both would know who got it, because there would be 2 emails.
So we will try to make the categorize the paper with the group of the peoples. Okay, maximum 2. Okay, but it is very difficult for our team to send 2 email to the same paper. Okay, same paper to be sent to the 2 persons. We will try to figure out by the today after the lunch. We will figure out how we will send to the. And if you have any doubt regarding the whether this suitable or not, then you discuss with me. Then we will try to figure out this question also. Okay.
So you have an active role in this course, okay? So you get to read something, you get to present, you get to talk, you get to share, okay? Finally, let's close with a smile. Major advancement in AI can now identify humor, right? Okay. And so that was the homework for the day. Those are the case studies: AI in healthcare, AI in manufacturing. So these are the areas. So in case you can take a picture of this if you like. There are 5 articles in healthcare, 5 articles in manufacturing, 5 in education, ethical AI, and 6 articles in the reason I call it distributed applications is not a particular sector, they are distributed, okay? So distributed applications in AI. And so we end with a motivational quote, and that is by Patanjali. When you are inspired by some great purpose, some extraordinary project, all your thoughts break their bonds, okay? So thank you very much.